Hello everyone, today we're going to take a look at derivatives and differentiating functions. Now to start off, you know right away when you have a derivative problem because you have the notation d over dx. So what that means is you're taking the derivative with respect to x. Now starting off here, we have a list of constants, and whenever you take the derivative of a constant on its own, it'll always be equal to 0. So the derivative with respect to x of 3, 0. Same thing, it doesn't matter if it's a fraction or not, so 7 over 10. Differentiating with respect to x, that's also going to be 0. Same thing with 100, it's going to be 0. Now, in this last case, even a number such as pi, that's still a constant, so you guessed it, it's going to be 0 as well. Now, when we move on to working with variables, now you can see we have differentiating with respect to x, and we have the variable x in our function that we're trying to differentiate. Now, when we're working with these sort of problems, we need to introduce something called the power rule. And now what the power rule says is if you have a derivative with respect to x of x to the power of n, that equals n times x to the power of n minus 1. I think it's easiest just to show it in action. So the way I think of it is, in this first example, I'll take the exponent, 2, bring over our x, and then 2 minus 1 is just 1, so we put that up there for the new exponent, and this just simplifies to 2x. With this next problem, we have x to the power of 5 differentiated with respect to x. So again, we'll bring the 5 out front, times x to the 5 minus 1 is 4. And finally, we have 3 times x to the 4th. Now this brings in a little bit of a different situation because we have a constant multiplying by a variable. Now when you have something like this, you can rewrite it in a simplified form. Just say 3 times the derivative with respect to x of x to the 4th. And what that equals is 3 times, so you bring the 4 out front, times x to the 4 minus 1 is 3. And now you multiply that 3 through the bracket, that gives us 12x to the power of 3. Now continuing on, we'll add a little more complication here. If we're doing sums and differences with variables, we need to introduce the sum and differences rule. So I'll start off with the sum rule. What that means is if you're differentiating with respect to x of, let's say, f of x plus g of x, so these are two different functions, that is the same as differentiating with respect to x of the first function plus differentiating with respect to x of the second function. Now that's the sum rule. Now similarly, we get the difference rule. You might be able to guess. That means if we take f of x minus g of x, all differentiated, that's the same as differentiating them separately and subtracting them, or taking the difference. Oops. G of x. So it's fairly simple, just break it up into parts. So for this first example, I'll start off by doing 6 times x to the 6 minus 1 is 5, plus, and now we get 3 times 4x to the 4 minus 1 is 3, and that can simplify out to 6x to the 5 plus 12x to the 3. We did run out of space a little bit there, but that's okay. Let's continue on to the next problem. So here we have 2 times x to the 3 minus 3 times x to the 5. So again, break it into parts. So that is going to be 2 times 3x to the 2 minus 3 times 5x to the 4. Now I'll remove this to give us a little more space to simplify this out. So that just simplifies to 6x squared minus 15x to the 4th. Now in this last problem we have sums and differences in the same function, and it works just as simply as it did in the last two examples. So if we take, starting off with the first one, it'll be 4 times 2x squared, oops, not 2x squared, 2x to the power of 1, minus 2 times 5x to the 4, plus 7 times 4x to the 3. And that simplifies down to 8x minus 10x to the 4 plus 28x to the 3. And that's the main rules for working with differentials, and they're pretty simple when you break it down in this way. So I hope you guys learned a lot, and thank you for watching. Post any comments if you have any questions. Thank you.